Okay, hello everyone. Welcome back to our episode 21 of the series. And this should be the last episode because the only thing left in this book is the extra practice and the proof by induction. And I feel like I may not have enough time to finish it. It's quite a lot. It's really hard to make it into one video. So yeah, I believe at this point, if you keep following up to this final video, your math must be very good, and I'm so proud of you. And yeah, let's begin our final exercises. So the first one, which is a higher power of 2 that divides this. So we just going to take the floor of the number divided by all kinds of power of 2 to the 2, and we gonna add them up and we get the answer. So part B, for which of n does 2n divided by n factorial? Well, actually n equals to 0 is going to be the only solution because this bunch of floor is going to have a maximum of this. Okay, sorry, it's going to have a maximum of this, right? But this thing is clearly going to be less than n. Therefore, yeah, but okay, this is the power of 2 it has. This is the theoretical maximum, right? And so this maximum is going to be smaller than the value of n. But what we want is actually wait, I need to take a moment to see what did I do here. Sorry guys. Okay, 2 to the power of n. Oh yeah, so 2 to the power of n, it can't divide n factorial because n is always going to be greater than the actual power of 2 it has. Therefore, it is not possible. N equals to 0 is the only solution. So proof by induction, this thing, namely this. Yeah, I think the book making a little arrow here. If you substitute like n equals to 1, yeah, n equals to 1, this thing is actually equal. So we're gonna find out that this thing is actually less than 1. And when we are doing our proof by induction, we multiply this thing by the smaller size. So like it is smaller, this thing you multiply is going to get even more smaller, and we multiply that and we get the n plus 1 term and the right side boundary, and that's how you're gonna do it. And question 3, we're gonna prove that p appear in the prime power decomposition of this to the power of 1. So we're gonna know that this prime is not going to be showing up in n factorial. It's only going to show up in 2n factorial by once. Therefore, this whole thing is going to be only have that to the power of 1. And 4 is very similar. This thing is going to be appear bottom for 2 times, and this is going to be appear at the top for once, because wait, sorry, this is also twice, sorry, like this thing have two different n factorial, right? It's going to appear in n factorial, each n factorial by once. So it has two. It show up in two times. So one in n factorial, one in another n factorial. And 2n is going to be show up twice, one in this range and one in range of this double, and yeah, that's the second range. So, and that cancel out, the p is not going to be appear in this expression. So question 5. Okay, the last question. What you're gonna do is you're gonna sub in p the nth prime to the x over here, and you get this expression here. So we know that Pn is going to be the nth prime, right? And up to that point, there's a total of n different primes. Like the first prime, second prime, third prime, all the way to the Pn, the nth prime. This should be this is the last number that it is up to, and this is going to be the last prime it has. So this n primes, and we rearrange it, and yeah, we know we know that in order for the nth prime to be appear, there should be at least n different numbers, and we're gonna substitute this. Like, okay, we're gonna substitute this for n, and we get boom, and we get our final conclusion here. And just don't mind it, just put this to the left, this thing to the right. And for the chapter 22, there's no exercises. And I think we have officially done our number series. Good job. And yeah, maybe I will begin with our next series soon, and you may be looking forward to that. I think it's probably going to be me doing some programming problems, I guess, hopefully, because it has been a long time since we did any programming. And thank you for watching the video, and goodbye.